Okay, the next thing we're going to look at is some of the factors that affect terrestrial ecosystems, meaning the ones on the land. We're going to look at 4 main factors, but these by far are not the only ones. They're just the 4 that we're going to talk about. So the main ones we're going to focus on will be the soil, the water, the temperature, and sunlight. So the first thing you need to understand are the layers of the soil. So in your notes, make sure you fill these out. The top layer is what we would call the litter, and that's usually the partially decomposed leaves and grass, the stuff sitting on the surface. So if you go out right now with the snow melting, that's what you're going to see, right? The dead grass, the leaves from the fall that haven't quite decomposed yet, the stuff just laying on the ground. That would all be considered the litter. The next layer would be the topsoil, and this is where you have some of that decaying old matter that's turning into organic nutrients like we talked about in our matter cycles, but also little bits of rock and sand and the other things that are there. That decaying plant matter, though, you need to know this word right here is also called humus. And that's just a term that describes that decaying matter that makes up the nutrient-rich part of soil. Otherwise, it would just be rock particles. The next section down is the subsoil. Now, this is where you have less organic matter and more rocky, sandy kind of conditions. There may be a little bit of organic matter that's leached down from the upper layers, but probably not much. More just sand and rock and that kind of stuff. And if you keep going down, eventually you end up with the bedrock, which is mostly solid rock. And then depending on where you live, these layers can all vary in depth, in quality, and all those kinds of factors. So the other thing to think about with soil is that quantity and quality of soil of any of these layers can vary even from neighboring fields, from one yard to another even, or from one field to the next field, can vary quite a bit. So for example, you may have certain layers that are very shallow or they could be very deep. You may have very thin topsoil on a piece of property because of erosion or other factors, or you could have very deep, nice, rich soil. You might also have a really thick subsoil layer or a gravel bed that kind of is below a piece of property, depending on a lot of different factors that can be there. It could also be the pH of that soil. So some soil is very acidic while others are very alkaline. You may have noticed around here, if you drive past farm fields, sometimes you'll see a patch of soil that's kind of white and crusty, and that's usually an indication of a quite alkaline soil or a very basic soil, and some of the nutrients, the basic elements are forming a crust or like crystallizing on the surface of the soil, giving it that white appearance. And depending on the plants, some plants like more acidic soil, some plants like very basic soil, and some plants are really picky and will only grow in a very narrow range of pH. So if you were a very avid gardener, watching the pH of your soil is important. If it becomes too acidic or too basic, then your garden's not going to do as well as you'd like. The other thing to watch for is nutrient levels. So farmers, gardeners, people with flower beds would quite often add fertilizer to their fields or to their flower beds or their gardens because those nutrient levels need to be high in order for things to grow. Some soil has naturally quite high nutrient levels and some soil doesn't. But if you get nutrient levels that are too high, that's also bad for plants. So you need to be careful to try to maintain optimum levels of those nutrients, but not necessarily too high or too low. But any of these could affect what we would call the quality of the soil, meaning you might have a lot of it, but it might not be very good soil. My garden is a perfect example. It's really, really poor soil. Now, if I was a better gardener, I would probably know how to, over time, change the quality of that soil, but I'm definitely not there yet. So I probably won't do that. In fact, I'm probably just going to bring in some other soil and start over. That's how I roll. Okay, so that's the soil. The next factor is available water. So we know that plants need water to grow. We know that organisms need water to drink, and that organisms also need those plants to grow from. So part of that availability of water is the amount and type of precipitation. So do you get a lot of rain? Do you only get it during certain seasons of the year? You've probably heard of some places that have like the monsoons or the rainy season. Some ecosystems have a very rainy part of the year where they collect a lot of rain, and then for the rest of the year they're quite dry. Some places are more stable throughout the year, but maybe don't get as much. Southern Alberta, we're kind of a drier climate, although not arid to be kind of desert-like, although if you head more towards Milk River area, you get into more arid type of landscape. But we get a decent amount of water, which is why our grassland ecosystem is able to thrive. Not as much, though, as, say, the forests. So like British Columbia and places like that, they get much more precipitation than we would. Another factor is how long it stays in the upper soil layers. So some soil, because of the quality of the rock and the particle size, water soaks in very, very quickly. So even though it might have rained an inch, if that water very quickly travels deep into the soil so that the roots of the plants can't get it, it's not available to those organisms anymore. It's basically been removed from use. In other places, water will sit on the surface for quite a long time or become lakes and rivers and streams and things like that that allow some access to that water. And some of the water that does end up in the ground also becomes available as groundwater. So maybe there's a spring, or maybe there's some kind of other feature that allows plants to be able to access some of that groundwater, or even for humans to be able to drill down or dig down with wells and things like that to be able to access that groundwater. So there needs to be some available groundwater, otherwise the plant and animal life won't do very well. Okay, the next thing is temperature. So in Alberta, organisms need to be able to adapt quite substantially to temperature because our temperatures can fluctuate quite large. The temperature fluctuations can be quite large. So for example, in the summer we can get into the plus 30s, but in the winter we can get down into the minus 40s. That's a big temperature range for plants and animals to be able to adapt to. Excuse me. So one of the ways that plants adapt to temperature are these two plants above here. So we know that deciduous trees, like this one over here, in the winter they tend to pull their water, their nutrients and their stuff out of the leaves back into the like more wooded parts of the plant to protect it. And so they shed their leaves in the fall and basically go dormant for the winter. And that's one way that they adapt to survive in harsh climates like this, by going dormant. Now, some of those plants, if the temperatures become too severe, may not even survive the winter. Sometimes a tree or a shrub, even though it goes dormant, if the winter is too cold or too harsh or the conditions aren't just right, that can still cause the plant to die. And so the farther you go into the mountains or the farther you go north, you'll notice less deciduous trees like this and probably more coniferous trees like this. They can survive and actually do photosynthesis right through the winter. So you'll notice instead of big broad leaves, they have little narrow needles, we call them, although they're really just modified leaves. That smaller shape means that they don't need as much water. They don't need as much water to do photosynthesis, and they don't lose as much water through transpiration. That, combined with a few other factors, means that these plants don't have to go dormant. In the middle of winter, they will still be doing at least some photosynthesis with the sunlight that they get, although it's probably going to be lower, for sure lower than it would be in the summer. So you'll notice that they don't really grow much in the winter, but they do remain alive. In the summer, though, you'll start to see these new cones growing, like in this picture, or new kind of a deeper color of green needles starting to grow, where you can see where the branches are starting to expand and grow now that they have access to more sunlight and things like that. So it's a bit of a trade-off. Deciduous trees in the summer do really, really well because they have these big broad leaves to catch sunlight, and they can do a lot of photosynthesis. but that also means that it's a weakness for them in the winter where they have to go completely dormant. Trees like coniferous trees, evergreen trees, they don't have to do that because they've adapted to be not as efficient in the summer, but in ways that allow them to survive all the way through the winter. So it's a trade-off. That's one adaptation that they've made to do with temperature. So the first way that things have to deal with temperature is they have to adapt some way. A second way that animals and plants can adapt to this is by hibernating. Now, I want to clear up a little bit of a misconception here. Bears are not true hibernators. Now, I know that's probably not what you've been told most of your life. They do go into a dormant, kind of a sleepy state, but it's not true hibernation in the sense of the scientific meaning of the word. Something like a ground squirrel or a gopher is a true hibernator. If you were to dig down and find a gopher hibernating in their burrow, they would be asleep, out cold. You could basically pick them up and move them and they wouldn't do anything. If you were to walk into wherever a bear chose to hibernate, let's say a cave or a culvert or something like that, and you poked that bear, chances are that bear will wake up. It's just been sleeping. And even in the middle of winter, you'll see tracks where the bears will wake up. They'll go wander around a little bit, maybe forage for something, and then go back into their dens and go back to sleep. That's not true of actual hibernators. So it's kind of a form of hibernation, although not a true hibernation. But many organisms around here go into a hibernation, or at least a form of hibernation, like bears, where in that low temperature state where there's not a lot of food, they basically just store up a lot of energy and a lot of fat, and then they basically just sleep or rest through that season until things warm up and food will be available again in the spring. So that's another option. And the last one is to migrate. So some organisms, rather than adapt to their environment or to sleep through it, will just leave. So things like the Canada goose, we've all seen they fly south in the winter and then they come back in the spring. One you may not know are monarch butterflies will actually migrate all the way from Canada to Mexico for the winter, and then in the spring they will fly back all the way from Mexico. So it's one of, if not the largest insect migrations that we know of is monarch butterflies moving to escape their conditions. Okay, the last one is sunlight and temperature. And sunlight and temperature are affected by two different things. The first one in your notes is latitude, meaning where on the earth you are. So this line right here is the equator on this planet, and the flat horizontal lines on the earth are what we call latitudes. So if you are closer to the equator, you tend to have parts like this where the sun's rays hit you more directly. The farther you get from the equator, the more spread out those sun rays get, kind of like this. And so the temperatures tend to not be as warm because that sunlight is spread out over a larger area. The other factor that affects sunlight is the seasons, because depending on where you are on the planet, whether the sunlight is hitting you directly or whether it's kind of glancing off also depends on the season. So you'll see here where we are just coming out of right now, the winter, the sun's rays are hitting this part right here, the southern hemisphere is getting more direct sunlight. So Australia, parts of South America, they're in their summer right now heading into fall, while we're in our winter heading into spring. So you can see that the sunlight would be glancing off us right now compared to fairly directly hitting them as they rotate. Now the two equinoxes, the vernal equinox and the autumnal equinox, are basically when it's equal. The sun is basically directly over the equator, and for us, our day and our night are roughly about the same amount of time, although it's not entirely because of our latitude. And then the summer solstice on the other side is when we hit actual summer, about June 21st or 22nd, and that's where we are tipped the most towards the sun in the northern hemisphere. So we're actually going to be getting the most direct sun in about the end of June that we will get all year long, and then after that part we start to tip away from the sun and head into our fall. So those are the two things. The latitude and the seasons of the sun are going to affect how much sunlight we get, which will also affect how much photosynthesis is happening, how much energy is entering that ecosystem, and that's going to have a huge impact on terrestrial ecosystems. So hopefully that all makes sense. If there's anything in there that you have any trouble with or questions about, shoot me a message or an email, whatever helps, and I'll try to clear it up for you.